Start the recording. Welcome. Today is the Unit 3, Part 3 polar lecture of AP Precalculus. Triple angle is not relevant, and you should just know, you don't really need to know all of them. They're just like conversions between them using the sine squared plus cosine squared. Yeah, all the recordings can be found on the 5 YouTube. And this is also recorded and will be posted in the Precalc channel after. So welcome. We're going over polar today. So let's get started. First of all, the basics. This was prepared by me, and it's led by Lance, 5 is a student volunteer student initiative with 90 plus volunteers. And consider checking out 55.org because for pre-calc, most of the articles are completed. So it's a pretty good site, and even for calculus for our Calc BC kids here, it's useful for Calc AB and BC. So for all the calc and pre-calc, most of the articles are done. So check it out. And if you'd be interested in applying, here's the link in the chat again. And they're sent out on a rolling basis. And a quick disclaimer, AP is a trademark registered by the College Board, which is an affiliate with and does not endorse this resource on our 5 team. And now that we're done with that, some quick expectations that you've seen every lecture. Don't do something that'll get you banned. In other words, please follow all server rules. That means no AP Classroom questions, no spamming, no distracting in the chat. Like, stay focused in chat. Be kind to each other. Ask questions. And because there's no dumb questions, always ask them. And a mistake made now is a mistake you will make again later. And the same thing I've shown multiple times. 73% got a 5 and 90% got a 4 or above in pre-calc coming to lectures. So that's pre-calc from last year. This is going to be scheduled to be around 2.5 hours. Yeah, you're going to all be in the 72%. Actually, this year is going to increase to an 80%. This number is going to increase in 80% this year. Yeah, we're doing polar. So this is like 3.13 and 3.15. Oh, it's going to be 100. Oh, yeah, it's going to be 100, my bad. So I'm going to make this 100 this year. Alright, so now we're going to start with polar. So first topic is 3.13. So similar to our Unit 1 lecture, we're going to first go over like the topics, and then we're going to go and cover like questions. So first, the topics. So 3.13 is all about your polar coordinates and converting between rectangular and polar. So first, what is polar? Polar is a set of systems where you have r comma theta, where this is your input and this is your output. You plug in your input to get an output. And this is important for later. So remember that. This is your input, this is your output. It's flipped from our x comma y, where this was our input and this was our output. So now it's flipped. So remember that. Any questions about the input outputs before we move on? Nope. Cool. So then you have your polar graph, which pretty much is similar to the unit circle if you think about it. You have your angles, and it goes in degrees of pi, and you have like a circle of 1, a circle of 2, and so on. And it's pretty much just a way of representing points. And r is the distance from the center. And you have a conversion, which is the most important thing, which is very important for calculus, is knowing how to convert between polar and rectangular. So you have x is equal to r cosine theta. This is how you get your x coordinates. You plug in your r and cosine theta. So let's say you had 2 comma pi over 3. What is x? Did my things stop working for everyone, or? Okay. Okay, I'm gonna give like a second for people to answer. Yep, 1. So now we know x is 1. Okay, so now you have y is equal to r sine theta. What is y? square root 3. Yep. The way people are getting this is they plug into to r, and they plug in cosine pi over 3, and that's your unit circle value. So what value is cosine pi over 3? This is your unit circle value. So where, if you look at unit circle, cosine pi over 3 is here, so this would be 1/2 comma square root 3 over 2. So you would do 1/2 times 2, which is 1, and then 2 times square root 3 over 2, which is square root 3. Alright, so that's all that topic is about, converting. So now that you've covered that, we're going to go on to the next topic. I'm going to erase all that. We're going to go to the next topic, which talks about converting from x comma y to the polar world. So now we're going to the polar world. So now you have another formula which tells you r is equal to the square root of x squared plus y squared. Yeah, we're gonna do content then practice. Yep, this content will be pretty short. Yeah, it's your distance formula. It's similar to your circle formula. X squared is equal to r, y squared plus r squared. And then you find your theta by doing tangent. So arctan of y over x. Any questions so far about converting between the two forms? So this is rectangular to polar. Okay, sure. Okay, let's say we had square root 2 over 2, comma, square root 2 over 2. Or I'm gonna make this negative. What would be your r value? You don't need a calculator for this. What's your r value first? I'm gonna give like 20-ish seconds for people to try their best on this, and then we'll go over it. Remember, this isn't form, this is xy. So we're trying to find r comma theta. We have multiple answers. The answer for this one is r is equal to 1. And the reason for that is, if you were to do this formula, so that's the formula, we would say r is equal to the square root, I'm gonna need a lot of space for this, but we're gonna do r is equal to the square root of 2 times the square root of 2, because that's what squaring it does, plus negative square root 2 times negative square root 2. This would be all equal to what? What would this first term equal? What would this first term equal? Okay, we have multiple different answers. One half, yeah, it's 1/2. And then this will also be 1/2. So now we're saying r is equal to the square root of 1/2 plus 1/2. R is equal to square root of 1. R is equal to 1. Because, okay, if you were, okay, I'm going to move back up here. The square root of 2 times the square root of 2. The denominator will be equal to 4, and square root 2 times square root 2 would be 2, which would be 1/2. And then you did it twice. So that's it. Welcome. Alright, so now we found r. So I'm going to erase all this because we're going to need space to do the rest of this work. So now we're saying arctan of negative square root 2 over 2 divided by square root 2 over 2. What is this equal to? Yeah, that's one way to do it, but it's not always arctan of -1. Yeah. So what's arctan of -1? Yeah, and if I miss someone, Zaki's here to help as well. You don't need a calculator for this. This should be one that you know. Yeah, there's okay, so the arctan of -1 is -pi/4. Okay, the way you have arctan -1 memorized is if you think about your unit circle, right? There's only two values that give you a -1 or a 1. It's when your x and y are equal to each other, right? Because if you were to divide y by x, you should be able to get 1. So that means at pi/4, you would have that square root 2 over 2, comma, square root 2 over 2. Your other value would be -pi/4 or 7pi/4, which would be square root 2 over 2, square root 2 over 2, which would be -y. Yeah, if you have negatives, it makes it like a dash. So that tells you our coordinate is 1 comma -pi/4. There's also a bit more. It says in the polar coordinate system, the same point can be represented many ways. That's why you might have gotten 1 comma 7pi/4. You could also get -1 comma I think 3pi/4. Yeah, 1 pi -1 3pi/4 and so on. It's not only principal values. There's more. So you can have multiple values. I could go plus 2 pi continuously if I wanted to. Yeah. If I did -1 3pi/4, right? If we had our unit circle, our coordinates down here, right? But -1 3pi/4, that means you rotate it to here, and you went backwards -1 to back here. -1 is one of the alternative forms of your thing. Yeah, that's your range. So, but remember, a polar coordinate can have multiple forms, not just if it. Okay, it can't be 1 3pi/4 because where is our xy coordinate first of all? Square root 2 divided by 2 negative square root 2 over 2 would be positive x negative y. So that'd be like over here, right? So if you were to do 3pi/4, that would be up here. But if you did a -1, you would end up back here. You would end up back here. All right. That all makes sense. That's converting between the two forms. So I'm going to erase all this because now we've learned how to convert between the two forms. Arcs are restricted. Yes, they are restricted. But remember, we're in the polar world. We're not just on the topic of a restriction of domain. We're talking about the entire polar world now. The domain of arctan is from -pi/2 to from 2 to pi/2. That gives you your value, but it doesn't tell you all the possible values. It just gives you your what do you call it, reference angle. So you have to find you could use -pi/4. We said that was one possible solution. We said we could use one -pi/4. Another solution would be 1 7pi/4 because you could shift it by adding plus 2 pi or subtracting 2 pi. And that's because it's a coterminal angle. Remember that from all the way in the first lecture in 3.2? Talked about coterminal angles. Don't worry, if you missed the first explanation, we'll be doing more practice with these. Coterminal angle pretty much just means you have an angle that repeats. So let's say 2 pi, 4 pi, 6 pi, all coterminal angles because they all end on the same axis. Pi/3, and so on would be anything that ends on the same axis. And then finally, there's this thing about imaginary numbers, and you just memorize it. If it says represent in imaginary terms, you just do r cosine theta plus r plus I r sine theta. You just put an I on the second term and you do addition. That's all it is. There's not much to this. And you have to make sure that, yeah, this is on the test. Anything that's on this curriculum or the CED can be on the test. Yeah, it's I r sine theta. Yeah, oopsies. Maybe it was a bit hard to read, but 3.14. We are done with 3.13. That's all about your coordinates and stuff like that. Now you have your graphs. Yeah, pi day. That's the pi topic. So this just tells you that you have the I means imaginary. So this is like if you have to do an imaginary solution. Remember we talked about like you have an a plus bi. This is like that in the polar world. Yeah, because the y is a complex plane. Yeah. So now you have polar graphs, which we're gonna. You don't have to memorize all of them. You just have to know what they look like. And we're gonna get to that. That's the next page. But there's a few things you have to know. It says it's a function in terms of r. So you're gonna say r is equal to cosine theta. You can also have r squared is equal to something like cosine squared theta or something like that. You can have stuff that is squared. So you just have to have stuff that's like r is equal to something. And again, input is your theta and output is your r. And you can restrict your domain to find certain intervals. So let's say you had like a let's say you had like a pedal, right? You could restrict your domain just to have one pedal. But even though your entire function would be 4 pedals, you can restrict it just to be this one little pedal. Nope, your input is data. That's the most. Yeah, you'll be asked. You won't be asked to restrict it. They'll restrict it for you, and you have to find what the restriction is. And you'll see questions like that. We'll get to those. No, you cannot. Please do not. You will be banned. Uh, yeah. There's no FRQs on Polar, just MCQs. Yeah, they just want you to follow the curve. And my recommendation for this is to graph it out in rectangular form. Make sure to graph it out in rectangular form. Cause remember, these are they input. You won't see any polars on the FRQs, only on the MCQs. So you're gonna go. Let's say cosine, right? Cosine starts here. It goes down, up, right? These values tell you your points on your graph. So use that to your advantage. So this may be 2, this might be 0, this might be -2. Now that tells you where these points go. You don't have to memorize them. That's what I'm going over right now. You don't have to memorize them. You can graph them out each time. Especially in pre-calc with the generous timing, you can graph it out. In calculus, you won't have as much generous timing, so you might have to memorize it, but that's an extra issue for most people here, except a few people in calculus for the polar review. But nope, because you can graph it out, right? If you know how to graph your sine and cosine, you don't have to memorize it. And we'll go over how to use the graph. But remember, it's always the rectangular form. Yeah, graph it out in rectangular, and then you translate it to pi. Okay, now we're gonna go over. This is like from Google. I just found this random polar sheet with all the things. So we're gonna go over it. So you have this is missing one polar graph, which is your code, which is just your r is equal to a number. That's pretty much just a circle. That's it. It's just a circle centered around the origin. Not much to it. And data does not affect your data has no effect. Like for example, what happened? Okay, so let's say r is equal to 2, right? Is there a theta in this area? Is there a theta over here? No. So does that mean it can it affect your output? If there's no input, if there's nothing, yeah, it can't affect it because there's no value affecting it. Which is why you have another type of circle, which is one with theta, with cosine theta, cosine, sine, sine. If A is positive, cosine, this is the most important thing. If A is positive and you have a cosine, it'll be centered around the right side of your x-axis, always. If A is negative and it's cosine, it'll be centered around your left axis. If it's sine and it's positive, it'll be centered on the top axis. And if A sine theta is negative, it'll be centered around your bottom axis. And these are just circles, but now they're centered around a different point. Any questions about this? If A is 0, what happens if A is 0? If you have R is equal to 0 times cosine theta, what happens? Yeah, nothing. It would just be a point. It wouldn't even be a point. It wouldn't exist. So that's why it says A is greater than 0 or less than 0. It cannot be 0. Okay, next point. The cardioid. A cardioid happens when its A over B is equal to 1. And a similar idea happens in all of these, where cosine is positive. If A over B, if B is positive, it'll be centered around here. If B is negative, it'll be centered around here. If B is positive, it's centered around here. If B is negative, it's centered around here, if it's sine. And that's the most important thing, cosine and sine. That's what matters, and you can get to a 50-50 in like a second if you figure out which direction it goes. Most questions are just testing you on that. Yeah, I'll send the lecture guide after this, because I kind of made this a bit later. Let me. Yeah, I can send the polar thing, because I just found it off Google, but. Yeah, we're gonna do some MCQs. That's after these. Like, okay, I'm gonna just go a bit faster. Now, if A, okay, this is supposed to say A over B. If A over B is less than 2, you have a 1 loop lemnicon. You have no loops. If A is greater than B, if B is greater than A, you have an inner loop lemnicon. Same idea. 1 loop lemnicons. Yeah, these are like your what do you call it? These are like your dimpled limacons. These are what we call like dimpled limacons in pre-calc. These are just MCQ. Polar is just MCQ. Cardioid is your heart-shaped one, as most people would call it. And then the inner loop is the one with the inner loop. And that's when B is greater than A. A Limit or whatever, however you say this, is when you have if its cosine is centered around the x-axis. If it's a negative, now this is where it switches a bit. If it's a negative cosine, it's centered around the y-axis. There's multiple types of loops, so they don't tell you which ones are there on the exam. So as we saw on the CED, it doesn't tell you which ones. So yeah, it's a good review for AP Cal. You might get a calculator. But remember, at the end of the day, it's all based off your rectangular graph. So you don't have to memorize this. Just do -2, 2, and graph it out. This is sine. You don't have to memorize names. The test won't ask you, what is this graph? It'll say, which of the following is it? It'll give you the equations. You don't have to memorize it. That's the most important thing. Know how to graph in a rectangular. That's more important than that. This is not tested. It just shows you how inputs. This just shows you how data affects your R value. That's not much about memorization. And then your Rose curve, cosine has it's centered around the x-axis again. And if n is even, it's 2 n petals. If n is odd, it's n petals. And that's also important to know. This is another thing that's important to know. Any questions about how to find these curves? Archimedes is not tested. It's not tested in pre-calc. You might see it in calc. Yeah, cosine always has a pedal on the x-axis. It'll always have this first pedal over here. The H-shaped one might be tested. See, as we saw, right, this is the curriculum that College Board gives us, right, about polar function graphs. It doesn't tell you which graphs are tested. It just says a polar graph is something with inputs and outputs. A domain can be restricted. And you can have changes in distance. Yeah, sure. That's all it tells you. So no teacher except College Board themselves. I sent it in the chat. I can send it again. Okay, I'm gonna keep it on the sheet for another like 30 seconds, and then we're gonna continue. So any questions about polar graphs before we move on? How do you convert it to rectangular? To convert it to rectangular, we would say r squared is equal to x squared plus y squared. X squared plus y squared equals whatever this is. Yeah, they love their rose curve and cardioids. Those are the two they love the most. So those are the ones you see the most. Okay, next topic is rates of change in polar functions. Same idea we talked about before. What is your slope formula? Slope formula. How do you calculate? Yeah, y2 minus y1, right? y2 minus y1 divided by x2 minus x1. Okay, but now we're in polar. So what would be our y2 and y1? R, yeah. R2 minus R1, x2 minus x1. Remember, no calculus for this chat, please. So, oh wait, oopsies, not x2. Oopsies, my bad. Yeah, theta 2 minus theta 1. So this is your slope formula for polar. And this all we're going to go over in the next page, so I'm going to skip all this. This just tells you if you have an increasing to a decreasing, you have a minima or a maxima. The dy dx, that's calculus. Oh, you said delta. Oh, okay. And the average rate of change is your slope formula. So now this is rate of change. So there's a lot that you can see here, but we're gonna go from left to right. So this is rate of change. We're gonna spend a good amount of time on this for a little bit. There's no latex in this channel, so text is not in this channel, so for probably a good reason. But so if the function is positive and increasing, distance is increasing. If it's negative and decreasing, it's increasing. If it's positive and decreasing, it's decreasing, and if it's negative and increasing, it's decreasing. Okay, the rainbow's there for a reason. And I'm going to show you the rainbow for a reason now. So let's take this sine graph, right? Where it was graphed out. So you have your first part, which is this little part over here, right? In this part, your function is positive and increasing, so the distance is increasing. And now this part, you're decreasing, but you're still positive. So you're getting closer to 0. So that means you're decreasing. Here, you're increasing because you're getting farther and farther away from 0. Here you're decreasing, and here you're increasing. And the reason for the rainbow is it shows you each part of the graph connected to the other part. So this first orange part and this second orange part shows you this entire little part over here. This red part shows you this entire part over here. This blue part shows you this little part, and so on. Okay, any questions about this slide? This will come back near the end of the lecture. If they gave you just a polar graph, how would you graph it? So if you, let's say, if they gave you this function, right, f theta equals 1 plus 2 sine theta, you could graph it out exactly like this. And that's it. If you can connect it back to the rectangular graph, you will have an easier time. Yeah, there's no horizontal translation. Yeah. There's only vertical. You're not going to see a horizontal translation in this. What if they don't give you the function? If they don't give you the function, they're not going to be asking you to find distance usually. And if they are, we're going to get to that. So now, last part of rate of change, we're going to talk about minimas and maximas. So I'm going to give about 30 seconds to try to figure this out. These are all questions. So increasing, decreasing, or minimum, maximum. Is the real function the AP Precalc exam? I don't know what the real function is. Never heard of that. Alright. 30 seconds. Remember to spoiler your answers. Yeah, this is a question. You have to say, is it increasing, decreasing, increasing, and is it relative minimum or maxima? For the calculus people, this is really similar to what you do in calculus. So you should be able to answer this. Remember the spoiler. The graph is given to you. Okay, the answer is decreasing, increasing, minimum. Is there anyone that wants me to go over it? Okay. So, we're going to graph it out, right? That's our first step always. So we say we shift it up 3, right? And we have a sine of 2. So that means our max is going to be 3, 1, and negative 1, because we have to be 2 in between. And we have no shifts to our sine graph by itself. You don't need Desmos for this. So sine starts from the origin. I'm going to do this in a different color. We have sine. We're going to have a period of 2 pi, pi over 2, and 3 pi over 2, because you have to have sets of 4 intervals. And then we're going to graph it. We start at the origin, go up, back down, down, down. I'm going to change the color one more time so we can see this. So the function changes at 3 pi over 2. It changes from decreasing to increasing, which is a minimum. No, there will not be phase shifts. Phase shifts is past our level of. There's no polar. You can't do polar with a phase shift. If it was a cosine graph, for example, I'm gonna control Z. If it was a cosine graph, you would start at the top, you would go down, come back, boom, and boom. So at 3 pi over 2, we go from increasing to increasing, so it would be neither. But pi would go from decreasing to increasing, so it would be a minimum. The Unit 3 lecture that was part 1, which was like the basics, was like April 20th or something. April 26th. It was April 26th. Okay, if we just say relative minimum, it is absolute. But we don't know if there's another one. We don't care about the other ones. We just care about this one, so we're just saying it's relative for now. Negative decreasing thing. Oh, you'll see. It'll come back near the end. This would be a no calc. Yeah, you don't need a calculator for this. You might get a calculator, but it wouldn't really help you. So remember, all the calculator questions don't need a calculator. You can have a maximum. Let's say you had a shift, right? Let's say you had like a phase shift. Let's say you had like a pedal, right? If you had a pedal, then you could have stuff like that. Then you would have more periods. Then you could have stuff like that. Okay. Yeah, pretty much. They give you the calc when you don't need it, and they give you the calc when you do need it. Okay. And that is the answers. So now I'm gonna do another one. Similar idea, but I'm gonna zoom out because this is a bit longer. So similar idea. There's a question here, and there's a question here. Yeah, chill guys. Oh wait, I didn't see your question. Oh yeah, chill guys. Just slow mo's gonna go up. I can increase slow mode as needed. So lock back in or slow mo's gonna go back up. What was your question? Can you like send like a thanks? Okay. Didn't you say that getting further away from the x-axis is increasing? Yes, but there's another. This isn't asking about that though, because we're not at 0. If we were negative to positive, then it matters. No, in this case, this is shaded. It's shaded for you. But you wouldn't even need this. You type this on both sides of your answers. You put the horizontal bars. Oh wait, I'll show you. That you don't even need this graph. You don't even need this graph. This graph isn't very useful. Okay, I'm gonna go over the answer now, so we can get as many questions done as possible today. It's decreasing, increasing, and a minimum. Yeah, you could just do it with the given equation. Yeah, you don't need polar for it. Yeah, it's reflected. So if we were to graph it out, you would have -2. So that means your max would be 1. That would be 3, 1, -1. We'd still have 2 pi, pi over 2, 3 pi over 2. And then you would start at 0. We'd go down this time, back up. I didn't mess that up. No, I didn't. Okay. And then at pi over 2, we go from decreasing to increasing. Oh wait, oopsies, wrong one. Decreasing to increasing. Which is a minimum. Yeah, you don't need the graph. Did we use the graph at all? Oh, can you do it without the given equation and just the polar graph? Yeah, you could. It's a bit harder. So let's say they're going from this side, right? This is 0, right? What is happening as we're going closer? What's happening to our R value? I'm gonna zoom in for this. What is happening to our R value as we get closer to pi over 2? Decreasing. What happens when we get on the other side? Increasing. That's the same thing you found here. So you don't even need your equation either. You could do it with that. Hold up. Let me answer the first question. Carpetbaggers. Would they give? I just answered that. You don't need the polar graph. You can just do the polar graph. Um. Okay, you start from 0, right? You start from, remember, we go from 0 to 2 pi always, right? So for 0, would you start? You start here, and you're getting closer and closer. Your r is decreasing. So as theta increases, I'll write this bit bigger. As theta increases, r is decreasing. As theta continues to increase, r starts to increase at pi over 2. In the sine graph, wait, why did we start? We're going, because this is reflected. This is -2 sine. Okay, hold up. I'm gonna stop for a sec. If I missed your question, send it again. Or yeah, ping Zaki as well if I missed your question, because there's a lot of questions that I can't read all 44 at the same time. Alright, we're gonna continue now, and Zaki will answer your questions. Alright, now find the average rate of change over the interval from 17 pi to 12 from 3 pi over 2 of 4 sine 2 theta. You may, if you wish, you can use a calculator for this if you want to. These are calc questions because of pi over 12 and stuff. You don't need a calculator. You could try to solve it without it. You don't necessarily need one because you're divided by 12 and times 2 would cancel out to pi over 6, so you don't need one. On the exam, you wouldn't know. Yeah, these are angles we can go back to on the unit circle, yes. Are we allowed to on the exam? Depends on the type of question. Sometimes they show up in the non-calc, sometimes they show up in the calc, so it depends on your luck that day. Yeah, it depends on College Board, how they're feeling that day for you. Yes, you would need to know the unit circle to find your cosine sine values. Was it? It's asking you. Alright, so you don't need x and y values. Remember, your formula for this is r2 minus r1 divided by theta 2 minus theta 1. Because remember, we're in the polar world. Okay, we have 2 answers. I'm gonna give another 15 seconds. Yeah, these are your input values. So these were going in denominators. So I'm just gonna write it down. 3 pi over 2 minus 17 pi over 12 is equal to 4 sine of 2 times 3 pi over 2 minus 4 sine of 2 minus 17 pi over 12. And this all would simplify to negative 24 over pi. I'm not going to simplify this because that's going to take a long time. So, next question, very similar. Find the interval from pi over 2 to pi. Yeah, you can also just use Desmos. That's the next thing I'm going to show on how to do polar graphs in Desmos. And then we're going to start doing questions for the next 2 hours. Or, yeah, you just substitute the angles to the function. That's your theta. And then your r value is you plug it into f of theta to find r. Because remember, r is equal to f of theta. The answer for the previous question, I'm gonna have to put that in decimals because I don't actually know what negative 24. Yeah, it was negative 7.639 if you were to use a calculator. Okay, 20 more seconds and then we're gonna move on. Okay, I'm gonna turn off slow mo for a bit because everyone's locked in. So, okay, I'm gonna show in Desmos now. Okay, so now we're gonna pull up Desmos. I'm gonna split screen this for a little bit to showcase this. This will work. Alright, so we have Desmos, and we're gonna switch it to polar mode first. And we're gonna say r is equal to 4 sine of 2 theta. And now we have our graph, which we don't really need for this question, but just to show you how you do it in Desmos. It's not that slow. Yeah, you would do it like that. Yeah. So you would do pi over 2 minus 5 pi over 12. And I'm going to say this is actually f of theta. Oh, wait, yeah, that works, I guess. It doesn't show, if you do f of theta, it won't show in the polar curve. But it gives you your inputs and output values you need, so it works for this, what we're trying to do. Minus f of 5 pi over 12. Which is the same number. And that's because these are equal. Yeah, this would not be a non-calc. You could do this without a calc. You could do this without a calculator. It would just take a while. You could do pi over 2 minus 5 pi over 12. Okay, I can show it. Okay, now we don't need decimals anymore, so I'm going to put that away for now. Alright, I'm going to show you how to do one of these, just for this sake of it. That's going to take some time. You can do 4 or 3. Pi over 2 minus 5 pi over 12. And then our numerator. I'm going to simplify the denominator first before getting our numerator in. So we're going to get a common denominator, so 12, 6, pi over 12 is the denominator. Our numerator, we're gonna first find our values out here, because for the sake of space. So f of pi over 2 would be equal to 4 sine of 2 times pi over 2, which is equal to 4 sine of pi. 4 sine of pi, what's 4 sine of pi? 0. 0 minus, what's f of, now we're going to do f of 5 pi over 12. We're going to do 4 sine of 2 times 5 pi over 12, which is equal to 4 sine of 5 pi over 6. What is first sine of 5 pi over 6? 1/2. 4 times 1/2 is 2. 0 minus 2, negative 2. Negative 2 is equal to pi over 12. Now we're going to do keep, change, flip. We're going to keep the top, change it to multiplication, and flip it. And that's how you do it by paper. If you didn't have a calculator, this is how you do it. So it takes longer, but you can still do it without it. For the sake of time, we did with a calculator because you don't need to know. That's algebra. So now we're gonna start doing questions. Let's start with 3.13. This is, I think, what everyone's waiting for. This is from the MCQ Brian Passwater in the AP Precalc pins. You go to the resource document and you go to Brian Passwater MCQs or FRQs. This is non-calc. I'll tell you when it's calculated. This is non-calc. Alright, we're just gonna try to do as many of these as we can today. Make sure the spoiler and that was all the content, yeah. You learn all the content, now we're gonna practice it and apply it, because that's what's important. Not just knowing the content, but knowing how to apply it. So remember to spoil your answers, and now we're gonna keep going. Before we start questions, do we know how to graph polar graphs? No. Because you don't have to graph it, because it's MCQ. You just need to know the input and output and input. That's the most important thing. Know your inputs, know your outputs, know how to graph in rectangular form. Those are the tricks and tips for polar. Multiple answers. The answer for 126 is, I'm gonna let these last people answer the thing, is C. And the reason for that is, let's think about how to graph it. Okay, where would 7, 5 pi over 6 end up? Quadrant 2, okay? Now we're gonna do a different color. Okay, where would negative 7 pi over 6 end up? Okay, let's check that. Quadrant 2. This gives us pi, right? Because there's one negative pi. And then you have a little bit more. And that's negative 7 pi over 6. And that's it. If it was negative pi over 6, you would end up over here. So it's already, what time zone are you in for it to be 4 a.m.? That's gonna be a long night for you then. It's coterminal. Oh, okay. It's coterminal angles. It's minimum, yeah. Wait. 4:52 a.m. for you as well. Damn. Okay, next one, 127. Yeah, it's 4:52 for us. That's why my lectures are usually around this time, because it works for EST and PST normally. It's like a good time for both. Start when your classes start. Damn. Yeah, I start after school usually on EST times. I don't think that means I'm gonna guess you can't attend my. Oh yeah, reminder. There's a lecture tomorrow, the final lecture of the pre-calc lecture season. It's tomorrow at 8 p.m. EST. It's the cram lecture. Bring all your last final questions. It'll end exactly at 10 p.m. on the dot, so exactly 2 hours. At 10:05 p.m., the lecture stage will close. So, because people in EST need to go sleep, so this exam starts at that time for you. Crazy. Closing the exam at 6 p.m. Yep, you need to get good sleep, ESP people. PST people, it wouldn't work out if I did it based on that time zone, so give another 2 hours, CST, PST, all that stuff. The answer for 127 is A. Any questions? Anyone want me to do it? Alright, wait, someone wants, the way you do it is you're gonna graph it out. Where does pi over 2 end up? Which quadrant? Which quadrant? We're gonna say quadrants. We're gonna use mathematical terms. Quadrant 1, yep. Okay. And it's over here somewhere. It's 1, okay? Now we're gonna go down the answer choices. I'm gonna do these each in a different color. We're gonna start with A. we're going to go negative pi over 2. Oh, I think the answer, wait, oopsies. The answer key is wrong. Okay. Oopsies. I just looked at the answer key. I am actually, the answer key is wrong, I'm pretty sure. So, 1 over pi over 2. If you were to go to negative pi over 2, you would end up at this angle right here. Now you have to go negative 1, so you'd end up here, which means your angle is wrong. So it's not A. Oh, wait, pi over, yeah, oopsies, it's not on, yeah, I think, wait, hold up, oopsies. I'm not thinking right now. Alright. Pi over 2 ends up here. Negative pi over 2 ends up right here, ends up negative 1 right here. I did pi over 4. Yeah, I made the same mistake. So, it is A because of that. Okay, now let's look at B. Oopsies. Okay, now let's look at B. If we went to negative 3 pi over 2, we would have went pi over 2, another pi over 2, another pi over 2. We would end up here. But now we go negative 1, so now we're going to end up back over here. So now we went all the way back over here. Will coterminal angles always be a negative? They don't have to be. They can be, you could add 2 pi. So you could say this is 1 comma 5 pi over 2. That's another option. A was correct. Yeah, I messed up. Oopsies. My apologies. So, that's that question. Now we're going to do 128. Remember to spoil your answer, and we're going to continue on. Okay, we got some answers. This does not need a calculator. I'll let you know when you need a calculator. Okay, we got a few answers. I'm not really, the answer for 128 is D. And the reason for that is, you're going to graph it out. You're going to go to first pi over 3, which is over here. You're going to go negative 2, so now you're over here. Now I'm going to do a different color. I'm going to first start with A. A, we go to negative 2 pi over 3, which should be over here. And then we rotate, negative 2. That's not it. Now we're going to try a different color. B, we're going to go 5 pi over 3, so we're going to go all the way around to 5 pi over 3. I'm going to do that again, so we go all the way. 5 pi over 3, we end up here again. That's not it. Now we're going to try C. C, we're going to go to negative pi over 3, which ends up right here. Which means it's not C. This coterminal angle, yeah, that's what a coterminal angle means. It means an angle that shares the same terminal array. And then D is you go 4 pi over 3, and then you stop right there. How did the negative 2 become a 2? For which one? Wait, hold up. You know, like, oh, we're still doing 128. Hold up. Which negative 2 became a 2? There's a lot of negative 2s, so you're going to have to state which one. Yeah, negative radius. C is incorrect because I'm going to erase this and I'm going to do C by itself. So let's say A is negative 2 pi over 3. Pi over 3 is on this little circle right here, right? This ray. This little ray right here, if anything. So negative 2 pi over 3 means we're going to start at pi over 3 and we're going to swap it. We're going to flip it to the other side. And then let's look at C. C tells us we're negative pi over 3. Negative pi over 3 is over here. I'm really bad at drawing straight lines, but we're here. And it says we're at 2, so that means we don't have to flip anything. So we're just going to end up right here. Any questions about 128? Because this is the last representation question with multiple representations. The data point or the data value tells us where our angle ends up. That's what it matters for. It tells us where it matters. It tells us where we end up. Because without data, we wouldn't be able to tell us. Okay, so if you have, let's see. If you have a positive angle, right? I'm really bad. So let's say you have a positive angle, right? That means you're going to rotate counterclockwise, because that's how you rotate. But if you have a negative angle, you're going to rotate counterclockwise. Yeah, this lecture is recorded. It'll be pinned in the Precalc channel. It will take some time to get uploaded to the YouTube, so I'll pin it in the Precalc channel. Yeah. A positive angle will always go from 0, go around, and go to 2 pi. A negative angle will start at 0 and go backwards. Alright, make sure to fill a lecture feedback form before you leave, guys. Alright, so that's how you do positive and negative angles. And then our radius, so let's say we're gonna use this line. We're gonna say this line, right? Let's say this is pi over 4. A positive radius will tell us to be over here. A negative radius will tell us to be here. It'll flip across this line if it's negative on the same angle line. So it's gonna flip. Alright, so if that all made sense, we're gonna go on to question 129. Can you drop the reference sheet? Oh, like most of the questions are just the ones in the Brian Passwater. It's like pages like 30 to like 55. It's in the Precalc pins. The lecture guide I haven't uploaded yet because there was some changes made last second, so I didn't upload it yet. Let me just send the resources doc. Resources doc. It's like the Brian Password MCQs. Alright, 129. Actually, I'm gonna do polls now so I can actually see how many people are answering. So I recommend everyone answer from now on. I should be seeing around 20 answers, so like about half the people here participating. Minimum. No, because do you have an x and y in polar form? Oh, wait, is there a question? Oh, oopsies. Because they cancel out. That depends on the angle. It all depends on these angles. So first, go to your angle, then do your radius. That's why theta is your input, output is your r value. You have 17 votes. 3 more votes, guys. The formula for this one, I'm going to say the formula now, is x is equal to r cosine theta and y is equal to r sine theta. Yeah, I know, that's going to happen. I can't do anything about that, sadly, but the winning answer was A, and that was the right answer. Anyone want me to go over this? So the way you do it is you do x is equal to 2 cosine of 7 pi over 6. And we're going to do y is equal to 2 sine of 7 pi over 6. What is cosine of 7 pi over 6? Negative root 3 over 2, yeah. So negative square root 3 over 2 times 2 is equal to x. The purpose of the poll is just so that there's not like 20 messages per question, so I don't miss questions. No AP Classroom questions, please, and thank you. Y is equal to 2. What is 7? What is sine 7 pi over 6? Negative 1/2. Y is equal to negative 1. And x is equal to negative square root 3, which means negative square root 3 comma 1. A. Does that make sense for everyone? What's your question? It's negative 1. Oops, someone. It's negative 1. Supposed to be negative 1. Yeah, I forgot to write the negative 1. Okay. Now 130 and 131. We're gonna do both of them at the same time, so I'm gonna put 2 polls. Because let's speed this up a bit. So 130 A, B, C, D. 131 A, B, C, D. Can't vote for 130. Is poll closed? Okay, if it doesn't let you vote, just do like the spoiler. It says people are voting and the number is changing, so remember the spoiler answer. Put the bars around your answer. The answer for each question was D and D, and that was a question. How do I get cosine sine when the angle is negative? You just have to know your unit circle and like reflections. So let's say you have like 3 pi over 4. We know it's a negative x. We know pi over 4 is positive, right? It's a positive x value. But we know this is in quadrant 1. In quadrant 2, it'll be a negative x, so you just make your x negative. Do you want me to go over 130 or 131? Or is there a request to go over 130? Anyone want me to do 130 before I move on to 130? Nope. Someone wants me to do 130. Okay, 130, the way you do it is x is equal to r cosine theta. X is equal to -1 cosine of 5 pi over 3. And then you would say x is equal to -1 and cosine 5 pi over 3 is equal to, what's cosine 5 pi over 3 equal to? 1/2. So x is equal to -1/2. Okay, now I'm going to do y. Y is equal to r sine theta. R is -1 sine of 5 pi over 3. What is sine of 5 pi over 3? Yep, -1 times negative square root 3 over 2. Your negatives are going to cancel out, which means it's equal to square root 3 over 2, which is y, so that's d. Okay, for 131, the way you do it is you're going to do the same thing as always. X is equal to -4 cosine of negative pi over 2. X is equal to -4. Yeah, it's going to end around 6 probably. 6:30 at the latest. What is cosine of negative pi over 2? There is no link to this PDF yet. I will link it after the lecture. It is 5:14 right now, EST. Oh, okay, yeah, it's gonna end a bit earlier today because of Mother's Day, and I have an AP exam tomorrow, so I gotta study for that as well after. So, mix of both. Yep, AP Calc. We have another lecture at 6. What lecture is today at 6? Yeah, I'm a high school student, yeah. Oh, seminar starts at 6. BC. Alright. Alright, what is cosine negative pi over 2? Yeah, 0. So that means x is equal to 0. Now y is equal to -4 sine of negative pi over 2. Sine of negative pi over 2 is -1 times -4, which is 4, which is d. Okay. Okay. Now we're gonna skip this one. Wait, never mind. We're not gonna skip that one. We're gonna do this one because this is the other one. This is rectangular 2 polar. Yeah. No, it's not 0 comma 1. It's 0 comma negative 1. Because remember, negative pi over 2 is the same thing as 3 pi over 2. So you're just doing the sine and cosine of 3 pi over 2. If it makes it easier, you can add 3 pi or subtract. You can add 2 pi or subtract 2 pi to make it easier for you if you want positive angles. For 132. Okay, okay. There's some time to solve 132 now, so you're gonna have to wait a bit, but okay, 132. I'm gonna give about a minute, around a minute for this question. And the reason for the minute is that if you go faster now, when you go on the exam day, it won't feel as bad, the timings. And don't change your answer, guys, based off someone else's answer. It doesn't help you. It doesn't help that. It doesn't help anyone changing your answer. Okay, I see people changing their answers already. You might need to go over this one. That's why I didn't skip it, because I realized this is the only rectangular question. To convert from rectangular to polar, you have two formulas. You say r is equal to the square root of x squared plus y squared, and theta is equal to arctan of y over x. And now try it again with these two formulas. I'm going to give another 30 seconds with these two formulas. I forgot how to determine. Okay, you don't have to determine if it's a positive or negative. You can just shift your pi value. Remember, you can shift either or. There's multiple representations for these. Okay, the winning answer is D by 14, but I feel like people changed their answer. So the answer for 132 is C. This is why you don't change your answer. Okay. Or, okay, that's what the answer key says, but it's actually verify if it's right. Because I haven't used this answer key in a year. So let's check if it's right. So first step is we're going to find R. R is equal to the square root of negative 2 squared plus y squared. Or 0 squared, which doesn't matter, so I'm not going to count that. R is equal to plus or minus 2, because you can have a positive or a negative 2. Okay? Next part. Theta is equal to arctan of y over x, which is just 0. Which means this is going to be equal to 0, 2 pi, 4 pi. Next step, we have to look at where this coordinate is going to end up. That's another important thing. Now, radius can be negative. So we're going to look at where negative 2 comma 0 ends up. So if we graph out negative 2 comma 0, that would end up right around here. So now we're going to look through our answers. Our first answer, negative 2, negative pi. Negative pi does bring us to this area, but it's negative 2, so that flips it. So it's not A. Now negative 2, negative 2 comma pi. We go to pi, but then we do negative 2. So now we're over here again. So that's not useful. Next, negative 2 comma 2 pi. 2 pi brings us back to 0, and then you do negative 2. That works. And then 2 comma 0 just ends up right here, so it's not that. Okay. Any questions? Why -2? So if you were to do +2, right? This only 2, 0 would end up on the right side, but we're looking at -2, comma 0, which is on the left side. How would 2 pi work? Because 2 pi is equal to 0, remember? If you rotate it, it equals 0. Yeah, I would recommend graphing it out, doing your coordinates, points, all that. Make it as easy as possible for yourself. Don't try to do it in your head. Put the points down, do whatever you need to make it easy for yourself. Okay, any questions about 132? Our only polar, our rectangular to polar. I'd say they're about the same because that's where he made them based off the released questions. Okay, arctan of 0 is equal to 0, right? But remember, you can have shifts. So you can have 0, 2 pi, 4 pi. You have your coterminal angles. Coterminal angles is the most important topic of polar that you can shift and repeat as much as possible. All right, I'm going to move on now to some imaginary questions. Some good old imaginary questions. Arctan of 0 on it cannot be a um let me think. Yeah, it could be a pi as well. But pi wouldn't really help you either way, so yeah, I was gonna scroll down. Pi wouldn't help you either way. We're doing 133 now. So I'll have to poll again. The questions are from Ryan Passwater. So they're in the pre-calc pins in the resources document. But we're gonna be going over these questions together for the next like hour and a half. Hour to an hour and a half. Because polar, there's only another. We're on question 133. The max is 158, but we're not gonna do every single question. I'll show you, and then when we get there. For 132, 132 is C because 2 comma 0 would be you have a theta of 0, which means you would end up over here, and you have a radius of 2, so it means you don't flip. But our coordinate is -2 comma 0, which is over here, so it cannot be D. We're talking about coterminal angles. Because remember, arctan has a shift of pi, remember? It repeats every pi value. Okay, 133. There's only 4 votes, so I should put an I don't know option from now on. I'll put an I don't know answer from now on. Alright, the answer for 133 is C. And the reason for that is you're first gonna find the radius. So you're gonna do r is equal to the square root of negative 3 squared plus 3 squared, which means r is going to be equal to plus or minus the square root of 9 plus 9, or r equals plus or minus the square root of 18, which is equal to plus or minus 3 square root 2. And then theta is going to be equal to arctan of y over x, which is equal to arctan of negative 1, which is equal to negative pi over 4. So now arctan is equal to negative pi over 4. From there, we see there's no negative pi over 4, so we can't use that. So we're going to have to think about where our coordinate is. Where is negative 3 comma 3? Second quadrant, right? So now we're looking for it. Which angle of pi over 4 gives you a second quadrant angle? 3 pi over 4. So that means we know it's not A or B. And then from C and D, we know our radius was 3 square root 2. So let's see. Any questions? Yep. When do we use the plus pi? That's what you just did, actually. Oh, wait, hold on. Oopsies. That's what you just did. What is negative pi over 4 plus pi? D pi over 4. Yeah. I'm just trying to avoid using as many formulas as possible, so you have to memorize less. Better think about it logically than memorize a formula, because there's a lot of formulas to memorize. Focus on the ones you already have to memorize, instead of the ones you don't really need. Alright. Next question, 134. Actually, this is the same questions. Let me see. Is this the same? Yeah, it's the same. We're gonna do 136. I'll make a poll again. Oopsies. 36. A, B, C, D. Well, we went over the basics of polar functions. It's mostly just you have an r, you have a theta. Theta is your input, r is your output. and that's really it. And you can use your rectangular graph to find your um you can use your rectangular graph to find your polar graph. We can do one more of the other one after this because I want to do one rectangular. The entire thing is gonna be polar today. We're only doing polar, so today's only polar. Tomorrow will be whatever. Oh, on the exam there'll be maybe 2 to 3 questions, like max. Okay, so what did everyone get? We have a split between B and we have okay. 136 is B, and the way you do it is you're gonna look at this first coordinate. What is 4 cosine negative 2 pi over 3? The value, the value. We care about the value now. We're evaluating. All this is just you're evaluating. So yeah, negative 2. What is 4 sine of negative 2 pi over 3? Because if you were to do 4 cosine of negative 2 pi over 3, cosine of 2 pi, negative 2 pi over 3 would be the same thing as going all the way to this pi over 3, which is equivalent to 4 pi over 3. What is cosine of 4 pi over 3? This would be 4 times negative root 3 over 2. Oh, wait, oopsies, yeah, negative 1 half. Negative 1 half, which would be negative 2. And the other one would be 4 pi sine of 4 pi over 3 would be 4 times, which would be negative 2 root 3. And you can use your coterminal angle to find that. Yeah, you just have to do it on a piece of paper. You can't do trig in your head or any of pre-calc in your head. Only math you can do in your head is algebra 1, not even algebra 1. Addition, subtraction, multiplication, and division. And that's up to 12 only. After that, use on a piece of paper. Alright. What do you not understand about this question? It's just converting. So you're just evaluating this. This is your x coordinate. You're gonna evaluate this. This is your y coordinate, and that's it. They're on the 5 YouTube or on the lecture schedule, which I can send. You don't need to put anything in your calculator. You can just learn it. Oh wait, isn't our angle 2 pi over 3 since the angle will be the same as 11 pi over 6? Our angle is negative 2 pi over 3, which is the same thing as 4 pi over 3. Because you can do negative 2 pi over 3. We're going to add 2 pi to it, so we're going to add denominator 6, 4 pi over 3. Yeah, you need to know the formulas. Alright, now we're gonna do one more of these. We're gonna do 135, and then we're gonna move on to the next topic, which is the graph stuff, which will take some time, for sure. Okay, I gotta make a poll. Yeah, 1 sec. Where can you watch past ones? They're on the 5 YouTube, which I will send a link to real quick. Um, all of my lectures are on the 5 YouTube. Some of them can be found on the lecture schedule, which is this link right here, and you can find some of the old lectures there as well. It's an either or. Yeah, you could definitely catch up. Most of my recordings are really similar to this, where you just practice for a while. But we do have one more lecture tomorrow, so final lecture. I'm gonna send the link one last time. Yeah, each lecture is like 2 hours, so it's tomorrow at 8 p.m. EST. The answer that's winning so far, right now, is A, which I'm gonna guess a lot of people changed their answer for. 135 is A. And want me to go over it? Okay, sure. So, what is 3 cosine of 5 pi over 4? I do have a unit 2 lecture. It's just one full lecture. It's like 2 hours. It's like 2.5 hours. Just one big long lecture. There's no parts. Unit 3 is split into 3 parts, but unit 2 is just one long lecture. They're all in the Precalc pins, resource documents. Yeah, it's negative square root 3 over 2. Square root 2 over 2. What is 3 sine of 5 pi over 4? Yeah, unit 2 lecture was way too long. I'm next year gonna split that into 2 because I've realized that it's too long to do. Same thing happened last year. I expected it to be 2 hours. It went for 3.5 last year. Yeah, then if you want to just look at the last lessons, just like there's timestamps on my videos in menu ones. So you just have to do timestamp until like the log section. And then the other one would also be negative 3 root 2 divided by 2. So that would be your answer. Can you give tips for MCQ and FRQ? For MCQ, take your time. You have lots of time. Check your answers multiple times. You have the time to do that. For FRQs, you're gonna have to work fast. Practice. Look at the FRQs. They're very similar each year. And practice the style. Know your algebra because FRQ4 is all about your algebra. Know how, for FRQ3, know how to do your coordinates and finding your equation. For FRQ1 and 2, it's just know how to do your algebra still. It's know how to plug in numbers, find your inverse, and all that stuff. There's 4 FRQs. And remember, the non-calc MCQs are worth 44% of your exam. So if you do not do good on those, you will struggle with getting a good score. Okay. Now the polar functions. Okay, we're gonna go fast to these. These should be 15 seconds. I'm not gonna put a poll. Just type your answer out loud. No spoiler. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It's D. Cosine is negative. That's it. That's the answer. That's all you have to do. Just had to type the letter D. Okay, next question. Same. 10 seconds. 138. Go. 1, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yep, D. Cosine's positive. Next. Okay, now, okay, there's no timer anymore. These take longer. Okay. Now, my tip for this is graph it out. I'm not writing it, graph it out. But graph it out in rectangular form. It doesn't matter what this equation is. We do care about this, but graph it out in rectangular form. That's kind of what you're doing. When you're doing alright, so graph it out. I'm gonna let me see. There's like 3 types of these, so I'll do one of them. I'll do one live demonstration. So you're gonna first I'm gonna do this on a different page so there's more space for this because there's not a lot of space on this page. So I'm gonna take it here and we're gonna take a full page just for work for this. Start at the top. Alright. We're gonna graph it out. We don't care about what's happening up here. We're looking from where 0 to pi over 2, okay? What is our period? Remember, we have a b value. Pi, yeah, pi. So we have 2 periods then in this entire function. So we're gonna split this into 3 because we want to always do set. We want 4 points. So this is gonna be pi over 2. This is gonna be 3 pi over 2. This is gonna be pi over 4. 3 pi over 4. 5 pi over 4. 7 pi over 4. And this is a cosine. So we're starting at 1. We're going up to, because we found our period by doing 2 pi divided by b, and b is 2. Alright, so you're going to do cosine starts at the top. So we're going to start at the top. We're going to go down. We're going to go down again. And we're going to go back up. I'm going to do the entire thing. You don't need to do the entire thing, but for the sake of demonstration, I'm going to do the entire thing. So now you have to find from 0 to pi over 2. So we only care about this little part over here. Right? So we're starting at when theta is 0, we have a 3. So when theta is 0, we have a 3. So we're starting at A. We have a point A. So we know we have 1 point. Wait, hold up. I might have messed up. Wait 1 sec. The answer is C. And the reason for that is you're going from negative to positive, right? So from B, you start at B, right? Because we start at 0. We start at 0. Start at 0. What? Yeah, just follow the curve pretty much. That's pretty much the biggest tip. So at pi over 2, we're negative 1, right? So that means we're at E. That's our endpoint. We know that much. Right? Because at pi over 2, we're at negative 1. At pi over 4, we're at 1. Yeah, sure, I can scroll up. Yeah, this type of question is rare. You're probably going to see the converting one, and You're gonna see one converting one because that's very important for calculus as well. So sure. So you're gonna start from here at 0. Sure. All right. So our first answer says quadrant 1 from B to D. So we're going from B all the way to D. To end at D, that means our last value had to be pi over 2, 1. But our last value is pi over 2, -1. So it can't be A. Our second one says from D to B. So we're starting at D. Oh yeah, I did that. Okay, that's annoying. Okay, I have to do some different color, I guess. Okay. Because we're not starting at point A because it says the portion of the graph is consists of 2 pieces. One of those pieces is the portion from A to B. So this portion is already included. So this little part is already included. So we don't care about that. So we're going to look at this second part. And then we continue the loop from B to E. And if you were to sketch this out, it would look something, I'm pretty sure this is the way you would draw it. Actually, I don't know how to draw it. Yeah, I don't know how to draw it. Let's just say we stop here. And if you want to see this in Desmos, which I will pull up for demonstrations, because Desmos is better at graphing than me. We have 1 plus how's it in quadrant 3? Yeah, if it's okay, it's not really in quadrant 3. I'd say they're considering a quadrant 3 because it's on the polar axis. I wouldn't say it's really on quadrant 3. Alright, so we have our graph, right? I'm gonna graph that Desmos. So I'm gonna switch it to the polar curve, and this is how you switch. You click this little toolbar, and you click this polar curve. Now we're in the polar world. Fancy stuff. So now we're gonna start at 0. I'm gonna say this is like t, okay? I'm gonna add a slider, and I'm gonna say it goes in steps of pi over 4. So we're gonna start at, let's say, pi over 3. Yeah, it might be on the Calc PC FRQ, which I'm cooked for, but whatever. Pi over 3. So from 0 to pi over 3, we get this little part over here, but we have to go to pi over 2, so we have to go a bit farther. Pi over 2 takes us on this part right here. So it's actually not the way I drew it. It goes the other way, actually, but same thing. Shows the same idea. Yeah, if you were to do, I can't even erase this, but I'm gonna draw it here again. So we started from A to B, right? That's the first part. And then we're gonna continue from B to E. And if you were to graph out this entire thing, it was sort of, I think, look like this. Would be the entire thing if I remember drawing. It would look something like this if I could draw a straight line. But 1 is the midline, yeah. 1 is the midline. Because you're starting at +1. Okay, any other questions about this question? Can logic help us? Yeah, so you saw how we did logic, right? So from B to D is positive, right? So we know it can't be positive because we don't have a value that gives us a value up here. So it can't be A. It says from D to B is the same thing. It's just flipped. You just flip it around. So that's not helpful either. And then from B to A is the part that's already included. So we don't care about that. And it says the portion of the graph in quadrant 4 from B to A. So that's this part actually. That's this bottom part. And this is where the quadrant 3 comes from. It comes from being on the left side. Because I did it on the wrong side. Alright. Now we're going to do the next one. And we're going to do 140. I'm going to let you guys do this one. How do you know the order to draw the portions if you can't use calculator? So I'm going to do it on this one because I can actually erase the stuff because I can't erase on the other one sadly. So it says one section of the thing is already included, which is A to B. So we know it's starting at A and going to B. And you would just continue this path. And we knew that because we drew our curve, which says this is from A to B. And this is going to be from B to E. Alright, so now we're going to do 140. I'm going to zoom in so you can see more of it. Yeah, you don't need the top. I'm going to put the poll. Okay, I'm gonna give another 2-ish minutes for this. Oh, okay, you both have to go. Okay, see ya. Alright, oh yeah, lecture feedback form. I'll send that again before you leave. Okay, I'm gonna give another 15-ish seconds for this question. The answer for 140 is D. And you won't want me to go over it. Yes, okay. Okay, I'm gonna take another screenshot of this and then I will do this again on the other page because I don't have enough space on this page to show all the work. Yeah, that's what I'm gonna do. I would graph it all with rectangular. I cannot do it with the polar graph. Rectangular just makes more sense. Okay. So we have our graph. our equation is 3 sine 3 theta, so I'm going to write that over here so I can actually see it. So our period would be 2 pi over 3, because we would do 2 pi divided by b. So now we're going to have 3 periods on this graph. So we're going to have 2 pi over 3, 4 pi over 3, and 2 pi. And this is a sine, so we're going to have 1, 2, 3, 1, 2, 3, 1, 2, 3. Now we're going to find our points. So this is going to be half. So this is going to be pi over 3. This is going to be pi. This is going to be 5 pi over 3. And that's really all we need. So we're not going to do any more. So I'm going to switch this back to blue. We need to find our midline, which is 0. We're going to go to 3 and negative 3 because we have no vertical shifts. So sine starts at the origin. It's going to go up, going to go down, come back down, and come back up. It's going to go up, come down, and go back to the bottom. Go middle, up, down, here, and back to here. So now it says domain is restricted to pi over 3 to 2 pi over 3. So we're going to look at pi over 2 to 3. Pi over 2 to 2 pi over 3. So 2 pi over 3 is this part right here. Pi over 2, we can assume, is around this part, somewhere around here, right? Because pi over 3, pi over 2, somewhere around here. So we know it's probably like this little section over here. We don't know exactly where pi over 2 is, but we can assume it's somewhere around here. We could actually find it because this would be pi over 6 because this would be half. And that means each increment is pi over 6. So this would be pi over 2 actually. So this is pi over 2 to 2 pi over 3. So it's this little section, this little sliver right here. So we're going to look at we're going from a negative 3. So our first coordinate is negative 3 comma pi over 2 comma 0 comma 2 pi over 3. Well, you can graph it easily because remember we just found out that this is pi over 6 because this would be half, and then you would go in increments of pi over 6. So you could fill out all these values, but we don't need all of them. So we're looking for a point where it's negative 3 pi over 2. So let's do that first. We're going to go to pi over 2, and then we're going to go negative 3. That's C. Next point is 0 to pi over 3. Doesn't matter. So we're here. So 140 is D. And the reason for that is we're going from a negative value to 0. So we're going from a negative value to 0. The other one would be going from, we would be increasing on this interval. Yeah, sure. It's the questions. Okay, now questions time. Yeah, you're getting closer to the origin. Because we're getting from D to C, we'll be getting farther from the origin. Okay, sure. Alright, I need to explain on here because I can't erase. So we're starting from C, right? Because we know that we had 2 points. Negative 2, comma, oh, I forgot the points already. Negative 3, comma, pi over 2, comma, pi over 2, and 0, comma, 2 pi over 3. I would say graphing is the easiest way, personally. Because you wouldn't be able to find out where the points are unless you memorize each point. So you would start from negative 3 pi over 2 because that's our farthest point, right? Because that's where we started over here. We started from here. So that means we're starting from C and we're getting closer to the origin. So we have to get closer to the origin. If we went from D to C, we'd be getting farther from the origin. Not closer, but farther. Since we're going directly to the period and pi over 2 is the closest 1/4 interval, can we assume, yeah, C is at negative, it's at pi over 2, not negative pi over 2. It's at pi over 2. It's negative 2 comma pi over 2. This is C, this is D. It's not, oh, okay, so remember, that's why we looked at a rectangular graph, remember? Because we're getting closer. Our distance to 0 is decreasing. Alright, sure. So let's start. Alright, let's start from the beginning. We found our period. Does that make sense to everyone? We found our period, right? Does that make sense? That first step. I need yes from everyone before we continue. I'm gonna go step by step. Yes, okay. We found our period. We're gonna graph it out. Does that make sense how we found all these values? Does that make sense? Say yes again if it makes sense. Okay. Somewhat yes. Okay, what's the confusion? We're gonna stop here. We're gonna go with step by step. Step by step. No, because this is a sine graph. Remember, a period tells us how long until our values repeat again. So let's take an example of 2 pi, right? We started at 0 and went to 2 pi, right? And let me do this. This is a sine graph. So we would start at our max pi over 2, 3 pi over 2. You would start at your denominator. You would start at your lowest point in sine. You would go to your top. You would come back down. You would go back here and go back here. So that's what we did here. We started at our point, lowest, our 0. We went up, came back to the middle, went down, and came back up. Okay, so now does everyone understand? Oh wait, okay, your question. Why does it start from pi over 6? Okay, so that's another thing. So we can find all of our values by using something called we know our period is 2 pi over 3, right? So half of it will be pi over 3. And half of that will be pi over 6. Which means we increment in pi over 6. So we're incrementing in pi over 6. Which means this would be pi over 2. Okay. From there, now that we got to there, we know this is from pi over 2 to 2 pi over 3. That's what our answer tells us. So we don't care about that. So we're looking from a value that starts at negative 3, 0 and goes up to 2 pi over 3 at 0. So we went from a negative radius to a positive radius. Does that make sense? Okay. From there, we went, I'm going to do a different color now. We went from, so now we know we went from a negative to a positive, right? We can find this point, which is negative 3 comma pi over 2. This point, 2 pi over 3, is 0 comma 2 pi over 3. So we know we went from a negative value and we went towards 0. And that gives us our answer of D, because we went from point C to D. Now does that make sense? Will we ever have to know what the graph looks like in polar form? You can graph it out, so yeah. You can always graph it out. Okay, so we know this other side is in... we know this other side... I have to use a different color each time because of this way. We know it's not going from D to C because we'll be going from 0 to C because it says from D to C, which means we're going farther away. Like, you could graph your polar curve based off of this. Okay, I can show that. Hold up. So, I'm gonna do the sine graph because that's easy because that takes a long time to do a polar graph. So, we do sine. Okay, so this is 0, comma 0, right? So we start at 0. Now we go to the next point. This is pi over 2. This is 1. This is -1. We go to pi over 2. I'm going to do some different colors so you can actually see it. Pi over 2, 1. Now we go to 0. 0 pi, back to here. 3 pi over 2 is -1. And there would be a point at pi over 4 that would tell you the rest. So for smaller values like this, you would have to plug in more points. Hopefully that made sense. So now we're going to continue on to the next thing. We're going to do one more of these. We're going to do one more. And then we're going to speed through some other topics quickly. So I'm going to give a minute for this question. And I'm going to make a poll. It'll end exactly at 7, probably. I'll probably exactly end at 7. I was playing at 6:30, but I feel like it's gonna take a bit longer to get through some of the last topics. Three minutes, okay, fine. I'll give 3 minutes. Okay. First step, always graph that in rectangular. That's my tip. Graph it out in rectangular form. That's my best tip. Start with that. I started at 4 o'clock, so it's been 2 hours. That's not that bad. I've been longer before. Yep, that is correct for your question, XRX clan. Okay, at 6:11 your time is up, so I can't make this time bigger sadly, so 2 minutes left ish. Actually, wait, I can do the time. Hold up. Okay, that time should tell you how long. Gee. But I haven't said an answer yet. I haven't said an answer. No, that's the old poll. It's the old polls. All the old polls are slowly gonna start ending now because it's been hours since some of the polls have started. So you guys can work together to figure it out. That's fine. You don't have to. pulled so far. Okay, I'm gonna. Okay, I'm gonna go over it now. So, first step, graph it out. I'm not gonna say the answer until the end. I want to see if after I do the first few steps, maybe someone will figure it out. 0, 1.5, negative 1.5. And our theta is 3 theta. Yeah, you have to graph all the way. So because of that, I'm gonna do it on a different page because I don't have enough space to graph it out until there. So we're gonna graph it out. Soup 0, 1.5, negative 1.5. Oh, don't worry, it gets worse. Polar gets worse in calculus. You're not gonna have a fun time when you get to calculus polar. Maybe at the end I'll show you what calculus polar looks like. It's not fun. Period is 2 pi over 3. So I'm gonna do it in 2 subsections. So 2 pi over 3, 4 pi over 3. So then we have our 1, 2, 3, 1, 2, 3. Okay, it's the same as the other graph. So I'm just gonna reuse the graph because I don't actually know. I'll just redo it. 2, 3, 1, 2, 3. We know it's going from, it's a cosine graph, so we're going to start at a maximum. We're going to go down, up. Actually, first we're going to actually label all our points because we need all our points this time. So pi over 3, pi, 5 pi over 3. For here, we're going to divide by 2, pi over 2. Then actually pi over 6, oopsies, pi over 6. Now we're going to add pi over 6, which gives pi over 2. We're going to add pi over 6. What's 2 pi over 3 plus pi over 6? 5 pi over 6, yep. Okay, pi, and that's 7 pi over 6. What's 4 pi over 3 plus pi over 6? Simplified, 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 simplified. We care about unit circle values. Yeah, 3 pi over 2. 5 pi over 3 plus pi over 6 would be 11 pi over 6. So it's our entire unit circle. So we're going to start at our maximum. We're going to go down, up, down, up, down, down, up, up, down, down, up, up. Yeah, you'll have enough time. Remember, you have, for a non-calc question, you have 28. You have 28 questions in 80 minutes. So you will have time to do this. If you had to do this in the calculator section, you would have a calculator to do this. So it is an insane amount of time. So it says we're looking for this little section right here. So we're going at 0. So we need something with a 0. So we know we're going to go answer by answer. That's the easiest way to do this. It's MCQ for a reason. So we're going to start at 7 pi over 6. And we're going to go all the way to 4 pi over 3. So we start at 0, which does make sense. And then we go positive 1.5. Does that work? Hold on. Okay, let's plot the points. Where would 0, 7 pi over 6 does go? Right over here, right? It starts at the origin. Okay, where does this point go? 1.5 comma 4 pi over 3. Where does this go? Does that end up wherever it's supposed to be? Wait, where would 4 pi over 3 be? If you were to rotate 4 pi over 3, where would you end up? Which quadrant? Third quadrant. So we're somewhere around here. We're testing it right now. We're testing our points. Testing our points as we speak. So we know it's not A. 4 pi over 3 does not work as an answer. So let's try another color. Let's try 5 pi over 6 to pi. So let's try, we're going from 0 to pi 1.5. Yeah, it's the wrong quadrant. Yeah. So we start at 5 pi over 6, 0. That does work because we're starting at 0. And then we're going pi negative 1.5. So let's go to pi. Pi is on this side somewhere. But then we flip because it's negative. So now we're over here, which means it works. So it's B. Yeah, we're trying to find the exact values of the portion. Where's the negative? Because it says, we would remember, pi would be down here. It's a negative 1.5. Negative 1.5 is down here. So we have to flip it from our pi to positive, the positive side, pretty much. Okay, any questions about this? Yeah. Okay. You started. I can't even erase this, which is the annoying part. So. All right. Hold up. So we started from. I'm gonna do it on here. We started from here, right, at pi. Our coordinate was negative 1 pi, but this is positive 1 pi. So we need to like flip it to the other side, which would be now 0. This would be 1 comma 2 pi. Yeah, I'm doing one more session tomorrow. Yeah, at 8 p.m. EST, which I'll send the event for right about now. That point could be 1 comma 0, but do we have a 1 comma 0? What is the 5 pi over 6? 5 pi over 6 does nothing except saying you're starting at 0. How did we get positive pi? Because, okay, we have our, I'm going to do highlighters again. We have our pi here, right? Yeah, that's when the server shutdown ends. That's that's like the earliest I could do, pretty much. Server shutdown ends at 7, so I give an hour for people to get out of school from PST. And then our 0 tells us we're at 5 pi over 6. So our 0 is at negative 1. So we go from 0, which is our 5 pi over 6, and then we have our negative 1, negative pi over here. Or negative 1 comma pi over there, which gives us B. 8 p.m. EST. Between A and B, okay? Part A, okay. Answer A tells you that it starts at 0, right? Which is correct. But 4 pi over 3 is at 1.5, which means our coordinate would be somewhere over here in this area, which isn't helping us. This is 3.14. This is like finding sections. This is why I said I'm gonna skip like explaining it in the beginning, because it's easier to explain with a question. Because if I just said those words back then, you would have never understood them without me showing the graph right now. That's why I said I'd skip it and come back to it. So this is the last part of 3.14 that we didn't go over. Okay, we're gonna continue on, and then I'll answer questions as we go. Okay. Okay. 15 seconds. Go. I have to zoom out for this entire thing. Hold up. 15 seconds. Just say answer. 3, 2, 1. C. Cosine is positive. End of story. Okay, next one. 143. 10 seconds. If it was sine was sine is negative. If it was okay, A would be if sine was negative. B would be if sine was positive. This is cosine positive, and this is cosine negative. It's a rows, yeah. Okay, 10 seconds. This is 3 sine 4 theta. Three sine 4 theta. I'm gonna give another 5 seconds because this is a little bit harder than the other one. Yep, the answer is C. The reason is you have 4 theta. That means you have to have 8 petals. That means it can't be A or B. From here, we have C and D. If it's a sine, it will never start on your cosine. This is a cosine thing. Starting on your polar axis is a cosine thing. Okay, next. 3 seconds. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It is B. It is B because 2 means you're going to multiply by 2. 4 petals. Can't be this, can't be this. Cosine, as I said, starts on your polar axis. Next. 145. Oh, wait, there's a question. Hold up. Let me read. Do you all? No. It depends. If it's even only. If it's odd, you don't. Alright, go. Another. This is gonna be 15 seconds because this is a harder function. 145. Go. $145 is D. I need to fix the answer key for this, so I need to leave a comment on this. Alright, so the reason is sine is positive, so we're gonna be going like this. If it was, this is a cosine positive. Alright, we're gonna go back to that first thing. Remember that all the way back in the beginning we did that little like curve thing? We looked at our, if it's negative, if A is positive, it looks like this. It looks like infinity sign. If A is negative, it looks like an 8. If A is positive, it looks like this. If A is negative, it looks like this. Sine squared makes it do like this little H shape. That's really it. Okay. Now we're back to it. I'm going to go back all the way back down again, but all right. So, where were we? Okay. Next. 10 seconds. Oh my. Okay. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It is B because it starts on 0 and it's 3, so you don't multiply. Boom. Next. 147. What do we do? 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, D. Okay, wait. Someone. Don't send messages too fast. You're gonna get muted by the bot. Hold up. Let me read the. Let me answer the questions. Hold up. There's multiple questions. I just kind of skip some. How can it's even or odd? And can you go over the 1 up 3? Okay, I've never heard of the 1 up 3 down rule. How can you tell if it's even or odd? You look at your degrees. So like for example, in our last pedal it was a 3, which means it's odd. Look at the inside. Sure. So this is the same one. So because it's 3, that means we have 3 pedals, so we don't multiply. We keep it, it's odd. If it was a 2, it would be 4 pedals because we multiply by 2. So let's go through each answer. This does not work because we would start over here because cosine always starts with a pedal on the polar axis. This one would be the sine graph. This would be negative sine, this would be positive sine. Negative A, positive A. No, you look, so for this one, right? This was there's an inside 2, so you multiply. If it's even, you multiply. So this one was even, so we multiplied. And that's it. Alright. Can you explain the one with the exponent? Sure. Alright. So for the where was it? It was here. No, here. So you have a few different curves here. And this is mostly just memorization, or you can graph it out if you want. And pretty much what you do is it says r is equal to 6 sine squared theta. So that pretty much means you're having a value that repeats like every few. Remember our circle was like r is equal to 6 sine theta. It's like you have 2 circles now on the y-axis. So that's why it's this. Cosine would be these two. This is just a memorization graph. I would just recommend memorizing. This is cosine. This is sine. This is when negative A. This is positive A. This is negative A. This is positive A. Or something like that. This is just memorization. Or graph it out. If it goes to the right up, it's positive. Yeah. You probably won't see this one. This is a lot rarer. As you saw, most of them were roses in all the ones we did. Except that one. You don't have to memorize the name. It won't see like none of them have asked your name yet. Okay, yeah, 10 seconds, go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, B. Yep, okay. Any question? It's negative sign, so it's gonna be going down. That's all it is. Next, okay. We already did these, so I'm not gonna do them again. So we're gonna move on to the last topic of the day. Yeah, it's the other ones. So I'm not doing those. That's gonna take another hour if we do both of them. So we're gonna go on to the last topic of the day, which is gonna need its own explanation again. So I'm gonna go back to this page, which we learned about positive and increasing. You're gonna graph out your sine function or a cosine function, and you're gonna check, is the area, like this little area under the curve, increasing or decreasing? If it's increasing, the area is increasing. If the area is decreasing, it's decreasing. And that's all it is. So now we're going to go back to that question, and we're going to do it again based off that same logic. And for this, you don't need Desmos if you don't want to, but you may use Desmos if you feel like using it. Why do you have the colors? I just made it colored to make it easier to see and understand. And I also got it from my teacher last year in pre-calc. She like colored it for us to make it easy for us to understand. Yeah. Damn, she teaches a lot of subjects. I see. Our physics teacher only teaches physics. 2 to 3, around 2 to 3 on average. Yeah, sure. Let me make a poll. Damn. I would recommend graphing it because then you could see your increasing, decreasing thing that we're talking about. It's good for visualization. Visualization. Okay, I'm gonna give like 2-ish minutes for this, so I'm gonna pull up a timer for this time because I'm not very good at keeping times, so I'm gonna put a timer from now on. The amplitude is 3. Yep. Remember to answer the poll. There's no speed answers anymore. We're done with speed as earlier. Nope, because it's not. There's no shift anymore. There's no what do you call it, dilation factor. And yes, the midline is 2. Unless there's a graph from before, I don't remember. The period isn't 2 pi over. The period isn't 2 pi over 3 because there's no b value. When you like send your image, there's like a button next to it that says like spoiler. So let's, if I was to do this, yeah, you spoiled it, yeah. Okay, okay, the answer for this one is A. And the reason for that is, does anyone want me to go over it? Because if not, I'll go over like the harder ones later on. Depends. Wait, does someone want me to go? Okay, wait. If you want me to go over it, like put a thumbs up or something, because yes is not very descriptive anymore. There's too many people. Alright, someone wants me to go over it. Okay. Alright, so the way you do this is I'm gonna draft it small because you don't really need that much space for this one. So you'd say 2, 5, and -1. So we're gonna go until 2 pi. We're gonna have pi over 2, and 3 pi over 2. So now we're gonna start, it's a cosine, so we're gonna start at the top, go down, up, and up. So now we're gonna go, okay, and we know our area is gonna be decreasing over here because we're getting closer to the origin. Our distance is decreasing. So this is an area that's decreasing. This area, I'm gonna color code this. So this area is increasing. This area is decreasing. And this area is increasing. So now we're gonna go through our answer choices. So first choice says 5 pi over 6, 2 pi. That's this area right here. So that's like somewhere in this area. So that means it is A. But let's check the rest of our right answers. It says from 4 pi over 3 to 3 pi over 2. 3 pi over 2 is over here. But but our distance is not increasing, it's decreasing. So it's not B. Here it says the area is decreasing, but that's false because we're getting farther away from the origin. So it's not C. And from 4 pi to 3 pi to 3 pi over 2, it is decreasing, but it's not positive and increasing. It's negative and decreasing, so it's not D. Because, okay, so our points, right, like our section from pi to 3 pi over 2, this entire section is negative because it's a range. No, this is the last section, yeah, but there's still like a few more questions. So it's the same as negative and increasing, yes. So in summary, this table summarizes everything you need to know. So now we're gonna do 153. So I'm gonna give another 2 minutes for that. For nearing the end, this is the end of page 30, and then there's 33 pages in total. So we're nearing the end of our polar lecture for 2026. Yep, the end is near. And next year, I'll prepare a better lecture, hopefully, for the people who take it next year. Wait for calc. Yeah, the calc polar is not fun, but maybe I'll lecture that next year. Who knows? Maybe I'll be the one to lecture it next year. We shall see. Depends on how tomorrow goes. I'll decide if I want to lecture next year on calc. Thanks. Okay, minute left. Yeah, I'll make a poll. Oopsies. 153 A, B, C, D. I don't know. Make sure to fill the lecture feedback form before you leave so I can improve my lecture for tomorrow. Our one and final lecture. I would recommend graphing it out. My recommendation for all of polar is to graph it out. Like if you've heard in stats or physics, the recommendation is to draw a picture. This is graph it out. I would say for polar. If you've ever taken stats, most textbooks have like draw a picture. Stats isn't that bad. They're making it easier next year. Alright. For this question, for 153, the answer is D. And the way you do it, I'm just to go over it because I'm assuming people want to do it. So you first put your number line or your line. You're going to say it starts at 1, it's -2. So we're going to have a 3 and a -1. And then we're going to go all the way. And it says we have a period of pi. So we have pi, a 2 pi. We're going to split into 1, 1, 2, 3, 1, 2, 3. We're going to write out our numbers. We're going to have pi over 2, 2 pi over 2. Half of pi over 2 is pi. It's just because remember cosine has 5 values, 5 values. So if you split into 3 parts, it increments perfectly. 3 pi over 4, 5 pi over 4, and 7 pi over 4. So we know it's a negative cosine. So we're going to start at the bottom. We're going to go up, go down, go up, up, down, down. From there, we're looking for areas that, so we're going to look at each area individually. This area is decreasing. This area, I'm going to do decreasing parts first because I don't want to change colors. So this is decreasing. This is decreasing. This is the increasing color. So increasing, 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 increasing. Okay, now I'm going to look at colors. All right. Okay, any questions? No, okay, I didn't see any questions. So, oh, it is a question. Okay, hold up. I'm gonna look at chat now because I was not looking at chat while saying all that. Two pi is greater than 7 pi over 6 and 3 pi over 2. Okay, so we said we're looking for an area that's increasing. I'm gonna do a different color because this actually looks really bad. Increasing. So we're looking for a section that increases. So we're looking for a purple section in our case. So we're starting. Let's do 0 to pi over 6. 0 to pi over 6 is like somewhere over here. Like it goes 0 to pi over 6 is just this little green section because pi over 4 is less than pi over 6. So it's not A. Now we're going to look at B. B says from pi over 2 to 5 pi over 6. That's still green, so no. Now we're going to look from pi over 6 to 7 pi over 6. That's this section over here. No. Now we're looking from 7 pi over 6 to 3 pi over 2. Yeah, pi over 6 is less than pi over 4. And then finally, 7 pi over 6 is this little section over here, which is increasing. So check mark. Any questions on this? What's your question? For the increments, yeah. Yeah, you do the same for sine. So did I do a sine example? No, the last one was cosine, but it's the same. The same, because they both have periods of, it's always 3 increments in between. So you have your endpoints, 2 endpoints, and you have 3 increments. No, the period is always 2 pi, and then you have a b value, and you do 2 pi divided by b. And you have to adjust it as many times as you need to get 2 pi, because our interval is 2 pi. Alright, I like the, there's 5 questions left. We're not going to do all 5, because these questions are very simple. I'm going to give 15 seconds for this, because it should not take more than 15 seconds. So 15 seconds, just say your answer. You're saying leather. Oh, 30 seconds? Fine, I can give 30 seconds. That doesn't make much of a difference. It should take only 10 seconds if you know how to do it correctly. That's why I said 10 seconds, because it shouldn't take longer than that. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. I'm gonna do this in colors again because colors are very useful for people to see stuff. So we're gonna start with A to B. A to B is this line right here. Okay, we're gonna do all the colors first. We're not gonna do any thinking until then. B to C, it's the average rate of change. What is average rate of change? It's your slope or your secant line. So now B to C. B to D is this one, and A to D is this one. Which one has the most? Which has the least slope? D, yeah, because it's the most negative. That's it. That's why you need 10 seconds, because you have to draw 4 lines, see which one's the most negative. Okay. Oh wait, what's your question? You have a question, hold up. Is it D because decreasing while... It's more just that the slope... So remember we did that, like, in the beginning we did the R2 minus R1 divided by theta 2 minus theta 1. If you were to do that, you would get A to D is the most negative slope. Why not B to C? B to C would be positive, right? Because this is a positive line. So far, it's worked for all these questions, so I'd assume you can do it. It's because the ARC is negative, yeah. You could draw secant lines in, because remember, you're going from, it's the shape of this graph. All right. All right, next one. This should take, now that you know how to do it, it should take 15 seconds. Oh, you can't see the top point. Oopsies. I need to zoom like this. All right, there. There. Now I can. 15 seconds. Okay, so says which of the average rate of change is the greatest. So let's go through each of the answers. First, A to B. A to B is negative, so we know it's not that. Next, A to C. A to C is 0, so it's probably not that, but we can leave it. Next, B to C. B to C is pretty positive. And finally, B to D. So, depends on who you ask. The answer might differ. The key says D, because this would theoretically be where the data is the greatest. But I would argue that it would be C because data D is undefined. So on the AP Well, A to B would be a negative slope. So A and B won't be it. It's between C and D because these two would be negative or 0. What College Board say the answer is? It's a vertical line, yeah. So I would say it's probably B to C because this is undefined, but I can check real quick. Okay, so according to Google, a vertical line has infinite slope. So it is D based off that. According to Google, vertical tangent lines have infinite slopes. So I would say this is something that depends on who you ask. Because that means for every x value, you're increasing infinitely. Yeah, I'd say, is this the key to the? Is this the key to any RSC question, including Unit 1? Yeah, any RSC question is always just a secant line. Yeah, this would require more calculus knowledge to understand why D has an infinite slope. But this is like a question that I say wouldn't worry too much about. Okay. Wouldn't B and C have the same B to C and B to A? Okay, but remember, we're looking for the greatest slope, greatest average rate of change, which means we're looking for one that's positive. If it was B to C, right? That's positive, but B to A is negative. Because remember, a line would be decreasing negative. Or A to B is still negative. We have 3 questions left. So we're gonna do all 3 of these questions probably. Yeah, we're gonna do all 3 of these. 156. Okay, where the magic tangent line finder does not exist, like cusp. But yeah, I don't know what you're talking about, so I'm also cooked probably. Wait, no, wait, no, never mind. I know what you're talking about. 156. I'm gonna give like a minute or 2 for this. Yep, you guys are all getting 5s. Yeah, I'll put a poll real quick. Yep. For your question set, yes, it is. Yeah, this is the color grafting. I would say for this, any of these rate of change questions, just do the color grafting. Do the little parts. Okay, we have a winning answer so far. There's 4 FRQs and they're always the same type. They don't change. If you want to see that, it's in the precalc pins. I did a lecture on that yesterday. So it's in the precalc pins. I can also send timestamps for that actually. I'm gonna add timestamps because I also have the timestamps for it. So let me send the timestamps with the pin. So I'm gonna do that real quick while the timer goes for like another extra second. Okay, so now we're gonna go over it. We're gonna start here. We're gonna go here. 2 pi, pi, it's 0 for -4. We're gonna have our 1, 2, 3, 1, 2, 3, pi over 2, 3 pi over 2. We don't even care about all of these, so it just says pi over 4 to 3 pi over 4, so we only care about our first period. So now let's start graphing. We're gonna start, and this is a cosine, so we're gonna start at our top, go down, go up, go down, and go up. Now colors, we're decreasing here. We're decreasing here, our area is decreasing. In this area, our area is increasing. Here, our distance is increasing. So now, let's do some highlighting. Because what is the distance changing from pi over 4 to 3 pi over 4? It first increases, then decreases. We increased, and then we increased, then we decreased. Yeah, distance is it's this thing that's changing. We're looking for this thing. Okay, last 2 questions. Almost done. This is a little different, so I'm gonna let it go. What was the answer again? It was C. Because we went from increasing distance, purple, to decreasing distance, green. The average rate of change question the same as distance question? No. For this, I'll say use Desmos. For this one, use Desmos. Because actually, you don't need Desmos, but just for the sake of time, just for this, the output poll. Just for the sake of time, we're gonna do up. Will there be a question like this in a non-calc question? There could be. As I showed before, you can calculate it without you can calculate all of this without a calculator. What unit is the BC lecture on? This would be considered unit 9, like 9.5 and 9.6 of BC. Is polar allowing for this one? You don't need a. This is considered 9.9, but I'm not doing any of the calculus involved in that because this is still a pre-calc lecture, and I can't lecture calc until next year. So I'm gonna give like another minute. So. There's one more question after this. for your interval, you don't even need curly brackets. Yeah, above the x or below the x-axis. That's right. There's nothing else that could be. Yeah. That's why I said you can use calculator for this, just for the sake of time. I'll explain how you do it without a calculator, but I don't wanna. That's gonna take a long time to do without a calculator, so. It could be, but you have time on the exam. You have like 4 minutes a question or something, or I think 3.5 per question. I think it's 3 minutes and like 3.25 minutes per question, if I remember correctly. Okay, the answer for 157 is C. And I'm gonna show the calculator for this. It would just take a long time. The way you do it without a calculator is you would first plug in your points, right, to this. You would get positive or negative values. That if you plugged it in, this first part would tell you if whatever this is. So if it was above or below. If remember how we plotted coordinates before with our thing, you would find out is it below, above, and all that stuff. That's your second part. Your first part is doing you could do the R2 minus R1 divided by theta 2 minus theta 1 and solve if you wanted to do it that way. And then if you were to do it in Desmos, it would just be these 3 steps. You would first graph it out. You would restrict your domain to this. That would say it's below. Then I'm going to define f as theta, and then I'm going to plug it in, and that gives me a positive number, so it's C. Which means it was positive, and they're both below the x-axis. Yeah. So that's all this is. That's the old one. Let me open the last question. Last question of the day. You restrict the domain by. There's like when you type your function, it'll let you like restrict it. So there's like 2 options to restrict it. So you just type your domain. You just type your 2 numbers. This is the old graph, but yeah. You don't have to use curly brackets. It makes the thing for you to restrict it. Desmos is nice like that and does the restriction for you. Okay, 158. I'm gonna give 2 minutes starting now. Yeah, after I restricted it, I found the slope. Our average rate of change, as you might say. Um, yeah, calculator. You can't graph this without. You don't have the ability to graph. You would have to just sit and plug points in if you wanted to graph it. So this is also another calc question. Okay, 50 seconds left. Oh wait, let me make a poll real quick. 58. A, B, C, D. I don't know. And don't change your answer. So 30 seconds left. Keep your answer. This is the last. Did you already get rid of? No, I can send it. Hold up, I can send the link to it. Give me a sec. I can send it, but I gotta copy this over. You can look at the Desmos link if you want to see like what I did on Desmos. All right, the answer for 158 and our last question of today is A. Okay, does anyone want me to go over it or nah? Yes. Okay. Whoopsies. Okay. The way you do this is I'm gonna pull up. I need to type down Desmos because I haven't actually typed down Desmos yet. So let me type down Desmos. R is equal to 3 sine theta cosine theta from. Actually, I'll just do it on the screen. Hold up. I'm gonna split screen this. I'm gonna have to zoom out. I'm sorry, but pi over 2, 3 pi over 4. All of it is below the x-axis, so we know it's not C or D. From there, it says we're getting closer to the origin, so we're gonna graph it out like our way we did before. So f of theta equals 3. I'm just gonna copy this. Equals r. No, but does not work. So now we have our graph. I'm gonna restrict the domain from pi over 2 theta to 3 pi over 4. Please not joke about cheating. Just click this wrench here. So you should click this grid. So our graph, as we see, because this is, okay, hold up. Let me go back to the other graph first, because this is not very useful for these purposes. So if I do this, I'm gonna copy paste this into a new line. So we have this. And as it shows, we're getting farther away from the origin because our area is increasing. I can't actually shade on this. Actually, wait, no, I can. Wait a sec. I can shade on this, draw on screen. Our area is increasing. So it's A. Okay, that's now we're done with all I would say this would be a calc question because you would struggle to graph it, but you could also, like how we showed before, you could also sit and plug in values for any sine and cosine. Wait, which subject are you in? The one that just said that. Which subject are you in? Like the Okay, any questions? Questions, comments, or concerns? I'm gonna stay on the screen for 30 seconds. There's no questions asked. How was it A? Because our points were below the x-axis and they were getting farther away from the origin because our area, if I can find the graph I used, was okay, not gonna work. Okay. Our area was increasing over this interval. Thank you. Okay, any questions? Final questions, comments, or concerns? Do you know how much you have to get in the exam for a 5? I would say if you get above an 85, you're probably set. People say it's around like a 68% on that score site. If you get the non-calc MCQ wrong, a ton of them, you're gonna struggle to get 5, 6 game. Yeah. Okay, any final questions, comments, or concerns? Okay, if not, I'm gonna end the recording now.